Hello everyone, welcome to my channel. So in this video, what we will discuss, the new topic name is pyrometer, right? I am Subhrajit Sahu, Assistant Professor in Narasimha Engineering College. Today discussion, we will start from this pyrometer, one of the very interesting temperature measuring instrument. And before starting the discussion on pyrometers, let me tell you some basic things about the pyrometers, how it is working, on which principle it is working, right? Sir, in the image, this particular image, something is burning, right? Some hot wave is coming from the source, right? Generally, there are three modes of heat transfer: conduction, convection, and radiations. Everybody know, you know, I know, everybody know, right? Conduction, convection, radiations. Sir, now in this image, radiation mode of heat transfer is shown, right? It has been shown in this image, radiation of heat transfer, right? This is also the sun rays coming to the earth surface. The hot waves are coming in the form of radiations, right? Sir, why I have shown this image, right? Is it linked to this my today topic? Yes, 100% it is linked. Sir, earlier, how many types of temperature measuring instrument we have discussed? We have completed the discussions. Those are contact type. Contact type. Right? Thermocouple, thermistor, RTD, glass tube thermometers, everything are contact type. That means the sensing element of the instrument has to be touched to the surface of a body whose temperature is to be measured, right? The sensing element of the instrument definitely comes in contact with the hot surface or any surface whose temperature has to be measured. But there is a problem. We cannot do the same thing always. Most of the cases, we can use the contact type, but some special cases are there where this contact type temperature measuring instrument will fail fail to measure, it cannot measure. Sir, what are those cases, sir? Sir, those cases where the temperature is very high. Where, sir, it is found generally? In thermal power plant, cold fired power plant, where coal is burning at a very high temperature generating there. In that case, contact type is felt to monitor the temperature or measure the temperature. This is one case. Second case is what? Second case is uh, any casting industries where molten metal, the product is producing from the molten metal, right? That area also very large amount of temperature is required, very high amount of temperature is required to convert a solid object to liquid object or a solid state metal to liquid state metal. So in that case also, this contact type temperature measuring instrument completely fails to monitor the temperature or measure the temperatures. Not only this one, there are several case applications are there. I will tell at the end of this topic. But right now, I hope you understood what is our topic today, right? It is the special temperature measuring instrument, which is measure the temperature without contacting the surface of a body. So if it is without contacting the surface of a body, then definitely it is work on radiation principle. That's why I have shown this image. Radiation principle. Sir, you know radiation principle is what? Radiation principle by the Stephen Boltzmann, he gave a beautiful statement that the total radiation is proportional to fourth power of the surface temperature. Fourth power of that body surface temperature, right? Now here radiation is coming at particular distance we have to maintain, right? That distance. So total radiation is the fourth power of the surface temperature of that body. And if we'll simplify, it become E equal to K or sigma. Both symbol in some book K is there, in some book sigma is there. K or sigma is called Stephen Boltzmann constant, K to the power T4, and K value is 4.876 kilocalorie per hour meter square Kelvin to the power 4, or 4.876 into 10 to the power minus 8 also there, minus 8. Similarly, 5.67 into 10 to the power minus 8 watt per meter square Kelvin to the power 4. So these the K value, Stephen Boltzmann constant value at different units, right? So what is our topic today? What instrument we are going to discuss? That is working on the principle of radiations, right? Radiation principle. So I hope this principle you ever previously, because conduction, convection, radiation, it is a common concept. Everybody has a little bit knowledge on that. So anyway, here we are going to discuss this principle only, on this principle, this temperature. Sir, what is this one? Have you seen this device? In the corona time, most popular this one, right? Wherever you go, medical, any railway station, bus stations, airport, wherever you go, they are using this concept, this instrument for measuring the temperatures, right? This is a pyrometer. This is also a pyrometer. That means no need to contact this machine, this instrument to human body. Just keep certain distance from the human body and it can sense the temperature, body temperature, right? Just like this one, just like this radiations, right? But this temperature device, this temperature measuring instrument, and what we are going to discuss, that is different. This is used to measure low temperature. Low temperature means our body temperatures or more than that. But what we are going to discuss, those are using in the industries. I told that the applications, molten metal for casting industries, power plant, thermal power plant for the steam generator, coal fired steam generators, in those cases where the temperature is very high, around 3500 degrees Celsius to 4000 degrees Celsius. In those areas we are using this one, right? Okay. This is also a separate type pyrometers. This figure, separate type pyrometer. Sir, pyrometer is classified into two types. Right? Two types. One is radiation pyrometer. Next one is optical pyrometer. Optical pyrometer. Right? Today I will discuss this radiation pyrometer. Right? So radiation pyrometer means on the basis of radiation or hot waves coming from a hot surface, we are going to deal with that hot radiation or hot waves and we will measure the temperature. So how it is? Through the construction we can understand. Through the diagram of that instrument we can understand. Here, three diagrams I have given. Okay, any diagram you can do, all are correct. All are correct only, right? some different book, different diagrams are there. I collected. This is the one diagram. See what is the arrangement, sir? This is the hot surface body, hot surface where the radiation is coming. Where the radiation is coming. This is my instrument. This one is my instrument, right? This one is my instrument. Now see, this is a cover housing tubes, right? Housing tubes. And here for viewing to inside, some hole is there. We can call it as eyesight. Eyesight, right? Eyesight. And this one is rake and pinion arrangement. Rake and pinion arrangement, I hope you know, like this. A circular gear and a horizontal gear like this, right? This type of arrangement is here, rake and pinion arrangement. To this rake and pinion arrangement, the lens, this is the lens. This one is the lens, right? The lens is attached. Sir, why it is attached to this rake and pinion arrangement? Based on the radiation direction, we can adjust this one top to bottom like this. We can adjust in this direction, top to bottom. We can adjust based on the radiation coming in. At the top level, bottom level, where maximum amount of radiation coming, we can adjust the lens by operating this rake and pinion. And here, one thermocouple is there. No, same thermocouple we are using, but thermocouple is not directly touched this temperature source. It is kept certain distance away from the temperature source, and the total arrangement is different as we previously discussed in other temperature measuring instrument, right? It is totally different constructions, right? So this is the thermocouple for the temperature measuring instrument. I hope you know how this thermocouple is working. This is the hot junction and this one is the cold junctions, right? This is the cold junction or reference junction, we can say reference junction. And here for voltage measurement, proper arrangement is there. Voltmeter we are using now. And to keep this hot junction safe side, one shield is used. Shield protections in welding we are using face shield, right? Face shield for protect our face. That's why like that. Here also to protect this thermocouple, we are using the face one shield, radiation shield, protection radiation shield, right? So this is the overall construction of this. Radiation type pyrometers, right? This is also same constructions, but here no rake pinion. Total the top to bottom lens is covered here. That's why pinion arrangement is not required. Rake pinion arrangement is not required. And here also same. What is the difference between this diagram, sir? Difference is here the sensing element kept before the lens. Here also before the lens, but here first lens then sensing element. Okay, it is also fine, no problem. Anyhow, we have to concentrate the radiations at this end only. So you can do in this way also, or in this way also, or in this way also. Which diagram is suitable for you, you can remember, but working is same for everything, right? So how it is working, observe carefully. Now the radiation is coming from this hot source, like this radiation is coming, and it is striking this lens. It is a concave lens, right? It is a concave lens. Is striking the lens. When it is striking the lens reflecting back, and all the incident rays are meeting at one point. It's meeting at one point. And at that particular point, we kept our hot junction of this thermocouple. So once this radiations after reflecting back from this concave lens, once it is concentrated on this hot junction of the thermocouple temperature will be rise, and this junction become more hot, and this junction is reference temperature which is the 0 degree Celsius. So there is a temperature difference created, delta. temperature difference created. Due to the temperature difference, as per the properties of these two materials, automatically voltage will be developed in the circuit, and how much voltage is developing we can able to measure by this voltmeter. So once here temperature rise, voltage also rise. Temperature rise, voltage also rise. So here temperature and voltage directly proportional to. So once I able to know this voltage value by doing this kind of arrangement, then I can convert this voltage in later to a suitable through a suitable calibrated scale to temperatures, right? This is the working of radiation type pyrometers. Very simple working. Little bit the figure is difficult. Construction is difficult. 2 to 3 times you practice, easily you can remember. This diagram also same. Here also this one. Same here also same, right? The working principle addition. Sir, how many thermocouples used here? Here one thermocouple, here one thermocouple, here one thermocouple. Sir, can we use multiple thermocouples here in this case? Yes, why not? We can use multiple thermocouple to increase the accuracy of this instrument. You can use the multiple thermocouples. So this one, this one is used multiple thermocouples, right? By using the multiple thermocouples in series, what is the benefit, sir? Benefit is this instrument can sense less radiation also, very less radiation, where heat is not so high. If you use multiple thermocouples, then the instrument also can able to measure the temperature at low heat area, low heating area, or less radiation area. But if it is the radiation quantity is more, the heat quantity is very high, then unnecessarily no need to use 2-3 thermocouples. One thermocouple is enough. Like this situation, right? Where this situations, I told casting industries is there, glass manufacturing industries is there, thermal power plant industries is there. Like this, those areas, this kind of instrument is used where temperature is very high. So with one thermocouple, it can be give the proper reading of the temperature. But in the case where the temperature has to be measured and that area is very low, radiation is giving, in that case, single thermocouple may not effectively work. Okay? Single thermocouple may not effectively work. In that case, we have to use the thermocouple in series, like this thermocouple in series. Then the low radiation also can be read here, and it can be converted to proper suitable voltage. Once the voltage will be generated, we can convert it to temperature also. Okay, these are called infrared okay, temperature measuring instrument, infrared temperature measuring instruments. Okay, so this is the construction and working of this measuring instrument. The name is radiation type pyrometers. I hope you understood what I discussed about the construction and working. Let me tell you about these applications, right? Already told applications here. See, steel production industries, right? Steel production industry, glass manufacturing industries, power plant, what I told, power plant, metallurgy means molten metals, right? I told casting industries, molten metal, aerospace area for testing, developing high temperature components, right? Furnaces also we are using this kind of temperature monitoring instrument for record the temperature, right? What is the advantages, sir? I told it is non-contact type, right? So this is one of the advantages, one non-contact type. And fast response, high accuracy, especially high accuracy it can give, right? And most important is what, since it is non-contact type, if the object is also moving, the hot surface body is moving also, we can able to measure the temperature, right? Moving or inaccessible objects, right? In that case also we can measure the temperatures. Sir, disadvantages is also there. What is the disadvantage, sir? It cannot be suitable to measure the temperature. This industry oriented type I'm telling, not this one. Which one? This not this one. This is the medical sector we are using for the body temperature, human body temperature. I'm talking about the disadvantage in the term of industry oriented, right? So in the industry oriented, if the radiation temperature is 600 degree or 700 degree, then this kind of instrument is not much suitable to measure the temperature, right? Because radiation, if radiation properly will not come, then it is very difficult to measure. 700 degrees Celsius, we cannot reach there, very closer to the surface, and radiation also cannot come properly to this instrument. That's why it is not suitable to below 600 degrees Celsius. Other instruments are there, we can use in that case. Okay, and it is expensive. Pyrometer is expensive, right? And it's here not effective for low temperatures, right? Not effective for low temperature unless proper additional arrangement. Proper additional arrangement means here we are using low temperature or body temperature 40 degrees, 70 degrees, 37 degrees, 30 degrees. How it is working, sir? By using series of thermocouples, not a single thermocouples. And this series of thermocouples is called as thermopiles, right? The series of thermocouple is called as thermopiles. So thermopiles is used inside this device so that it can able to measure the low temperature or body temperatures, right? Okay, so one more disadvantages in the related to industry. I will tell what is the disadvantages means. Suppose here it is written smoke and dust particle. Ash particle is frequently coming from this thermal power plant with that hot gases, with that hot radiations. There is a chance some dust particle, ash particle will comes, and once it will come and it is touched to this, attached to this lens surface, this lens surface, then the lens will be become ineffective to I mean to radiate the that hot radiation to a single point if it covered by the ash particle or dust particle, right? So proper maintenance is required, periodically maintenance is required to this lens, or it may be replaced with a new one, right? So this is the disadvantages of this radiation pyrometers. I hope it is clear to all of you. In the next video I will discuss about the second type, another type of pyrometers, that is optical pyrometers, right? Optical pyrometers. So I will conclude here. Till then, you take care and bye.